And we're going to add to our definition of simplify for radicals. Yay. So, do you remember with fractions that if you had 3 over 5 and you multiplied the top and bottom by 4 to get it, like you had to do that when you're adding fractions to get a common denominator? You would get 12 over 20, and that 12 over 20 is equal to 3 over 5 because what you're multiplying is multiplying by 1. And in fractions, that changes what the fraction looks like, but doesn't change what it's equal to. Okay? In mathematics, math becomes more difficult when you have square roots in the bottom of your fraction. Historically, before calculators, there was techniques for like 1 divided by the square root of 2. You could find 5 decimal places in like, I don't know, an hour. But if you did square root of 2 divided by 2, you could find it in half an hour. Which saved you some time. Now we have calculators. You can do them both equally quick. So a lot of people feel like this idea of rationalizing the denominator, which we're going to take out our highlighter and highlight that. A lot of people feel like, well, is there still a purpose to this? The answer is yes. It comes back in calculus, very helpful. But for right now, you're like, if I wanted to know what 1 over the root 2 is, I can just type that into my calculator and get the answer. That's true. However, in mathematics, if we have a radical in our denominator, it is considered not simplified. But the way to get rid of a square root on the bottom would be to multiply the square root on the bottom. But if you multiply that on the bottom, you need to multiply by 1. Just like with fractions, this changes what it looks like, but doesn't change what it's equal to. Now, if I multiply the tops here, I'm going to get 1 times root 2, I'm going to get root 2. And on the bottom, root 2 times root 2 is root 4, which the square roots would just cancel and give you 2. The square root of 2 is called an irrational number. 2 is a rational number. And so changing the denominator from an irrational number to a rational number, we call rationalizing, making rational, the denominator. And it will be your job to always have a rational number in your denominator. What would you have to do if you had 1 over the cube root of 5? What do you think you'd have to multiply by? Close. Is 1 cube root of 5 enough to get rid of the cube root? You would have to multiply by another cube root of 5. You'd need 3 of them. Does that make sense? For cube roots? So this, if this one's rationalized, it would be the cube root of 25 over 5. And that would be considered simplified. So a question is not simplified unless there is no irrational number in your denominator. And that's what we're going to get to in example 3. These ones have square roots in your denominator. You need to rationalize. So I rewrite the question, and then I ask myself, well, what could I multiply the bottom by to get rid of the square root? Well, if I multiplied the square root of 7 by square root of 7, it would just become 7. That would be really nice. Which means I also have to multiply the top by square root of 7, so I'm multiplying by 1. Multiplying by 1, right, the blue part is equal to 1. Doesn't change what it's equal to, it will just change what it looks like. Now it's really nice because the bottom will now look like a 7. A square root of 7 times square root of 7 is square root of 49, which is just 7. In other words, those square roots would cancel each other out when they're multiplied by each other. On the top, technically this is in brackets, and you would have to Multiply that root 7 by everything on the top. Okay? 5 root 7 times a root 7. If you want to take your time, you would write this. And some of you are going to skip this step. 5 times 1 is 5. Root 7 times root 7 is root 49. Which is just 7, but that's what I can say. Some of you are going to skip that and just say that's 7. And some of you are even going to skip that and just say, well, then that's 7 times 5. And you're going to right away write 35. So if you're able to, you see the mental math, right? You're able to go right away to 35. I'm fine with that. Because the square root of 49 is 7. But sometimes when we go too quickly, we make mental math mistakes. So if you like to take things slowly and be methodical, then you could write 5 root 49. Now, 3 times root 7, that's just easy, because it's 3 times 1 and root 7 times nothing. It'll just be 3 root 7. This is considered simplified. It looks just as complicated as what we started with, I agree. But we no longer have a square root on the bottom. So if 50 years ago you were asked to get this to decimals without a calculator, it would only take you half an hour. Instead of the first one taking you over an hour. Both of them right now with your calculator take you 20 seconds. So a lot of people say, do we still need to do this? Well, technically this is sort of a little history of math lesson. This is more simplified because it would be easier if you didn't have a calculator to calculate this. So we get a little bit of history of math here. I'm going to draw a line right here so we can do B right beside it. Okay, I'm going to rewrite it. 6 root 2 minus 4 root 3. Root 18. And I'm going to do this question a couple different ways because depending on what you think and what you decide to do first changes the question. Once it's simplified in the end, your answer should be the same. It's another reason for mathematicians like to simplify, because if they made rules for simplifying, if everybody followed the rules, then in the end, everyone should get the same answer and they can check. Do I have the same answer as you? Then we know that we're right, or we're both wrong. But we at least have a way of talking to each other and having things the same. So, I'm open to suggestions. What would you like to do first here? We need to get rid of the square root on the bottom.
Multiply both parts by the square root of 18.
Perfect. I like that. That is what I was hoping someone would say. Multiply both parts by the square root of 18. Do you see that that would get rid of the square root on the bottom? One of our goals for simplifying is not to have that square root on the bottom. Perfect. So then, thank you. Or do you have a question?
Yeah, this times this.
It is a mixed fraction, 1 and 2/5.
Can I change it?
Yeah, no problem. So the root 18, root 18, perfect, that becomes 18. On the top, do you see that you would have to distribute this in? So when I do 6, root 2 times root 18, I would get 6 root 36, correct? Minus, and root 18 times 4 before root 54. Question is, are we done?
No.
No. Because the square root of 36 is just 6. So I can change that. 6 times 6, that'll become 36. Are we done with this one? Or is there a number you could break it down? I'll write it out. Times table. Is there a perfect square that makes 54? 9 times 6. Okay. So 9 times 6, and again, I'm taking my time and showing a bunch of steps here. Some of these you could skip. But it's not bad to write them all out. Do you see the square root of 9 is 3? That 3 comes out in front, what would I write? Not 7. 3 times 4? 12 root 6 over 18. Good. So now we simplified the radicals. Are we done? No. Why are we not done yet? You see, in all three of these things, there's something you could divide by. You could divide everything by 2. Is there something bigger you could divide by? 6. You can divide them all by 6. So if you have adding and subtracting, but there's something that divides all three of those, 2 different ways you can show it. One with no work. I divide everything by 6. This will give me 6 minus 2 root 6 over 3. This is the most simplified answer in the end. The other way you can show it is technically we can simplify it the best with fractions when we're multiplying. And do you see there's a common factor of 6 in the top? So if you like this method where you factor out that 6 and then show that these simplify to 1/3. You would get the same answer that way. Okay. Big breath, right? There's a lot of math. We look at everything we did here. Okay, you'd get a mark for getting rid of the square root on the bottom. Then you'd get a mark for distributing, but then you get another mark because it needs to be simplified further. I'm going to erase this. I'm going to do B again. To show you there's more than one way to think about this. I'm going to rewrite it again. And whichever way you think of, you can get the right answer. Okay? Method number 2. Method number 1 we did in green there. We multiplied by root 18 over root 18. Anybody want to suggest something different that we could do to start?
Simplify.
We could simplify to start. What could you simplify?
Root 18.
We could simplify the root 18. So this, because 18 is 9 times 2, right? And so the square root of 9, are you okay if I go right away to 3 root 2? Good. What does simplifying do for us?
So it makes the things easier.
Makes it a little bit easier.
Suggest we can multiply by square root of 2. So we have
Yes.
square root of 36. And it's just 6.
You see how we can now just multiply by the square root of 2, right? Because to get rid of the square root of 2, you just need the square root of 2. You don't need the 3 to get rid of it. You just need to multiply by root 2 to get rid of it. So up here, this will still distribute.
And we can also do like this with square root of 18. So we have square root of 36, and then we have just 6. Just another way.
Yeah, it could be another way. You could have started with the root 2 at the top.
Yeah.
That way too. We'll do that in third. We'll do that as the third way after. Okay. So do you see that the root 2 times root 2 makes a 2, and 2 times 3 would be 6 on the bottom. If I distribute, 6 root 2 times root 2 will just be 6 times 2, 12. And root 2 times this will be minus 4 root 6. Are we done? No. But now, what's the number that can divide all of those? A 2. If you divide them all by 2, I think that was a little bit faster than the other way. Also, what was nice about this is you dealt with smaller numbers. Okay? So simplifying first would work. And then what Henry was saying is, instead of simplifying, I could have done just this to start. Because that makes a perfect square faster, because 18 times 2 is 36. That would also work. So we have, if you can do it mathematically, you can do that as your next step. always would get you the right answer in the end. Sometimes this will be faster and easier. Sometimes this is faster and easier. So think about different methods, because if you think about those different methods, you'll start to get good at seeing, oh, I think this is going to be better this time. And I like that. But you have to do a little bit of pre-thinking. If you don't want to do pre-thinking, you can just go with one method and see where it takes you. But sometimes our numbers get really big, right? On a non-calculator part of your test, you're kind of like, I wonder if there's a way so I don't have to do such complicated mental math. If I give you a non-calculator part, and all of a sudden you're at the point where you have to do 31 times 29, you're like, uh-oh, that's really big numbers. I most likely made something harder for myself earlier on. So there's probably an easier way. All right, questions to circle on this one are 6, 9, 13I and 13II, and finally 4. You'll eventually, after we do 4, you'll have 13 I. So if you want to circle 13, because you'll have to do them all eventually, you can.